Welcome everybody to the Game Engine session. My name is Pascal. I'm the director of the Esri R&D Center in Zurich, where we work on the 3D part of JavaScript, so in the browser, but also on the desktop with CityEngine. And we also are doing experiments, lots of actually, with game engines. And I'm going to talk first a bit about game engines in general, what it is, plus also the comparison between the two big ones, Unreal and Unity. That was one of the questions I got a lot, like which one and how they compare. Then, some examples of like what people do with our stuff, and then finally some workflows, just some simple tips and tricks how you bring in stuff from CityEngine to Unity or to Unreal. And then I decided to go a bit into Unreal because that's a bit unknown. So give you a bit of the basics and principles of like how Unreal works. It's actually, it's a pretty cool program and interesting, inspiring to see. And then last but not least, an exciting project we are currently working on, which is basically a VR template, a VR experience for urban planning. So this is work in progress, and can talk a bit about that at the very end. So first, introduction to game engines. Before I start here, like who used Unity or Unreal once? Okay, very good. Who Unity? Okay. Unreal users? Oh, okay. See? Okay, perfect. Let's start. So when you, for example, Google architecture visualization, then you see all these nice pictures about redevelopments and about new buildings and about plans, what's going to be built. And what's very interesting is basically that Unreal is, and a game engine is the fourth most used renderer for these things. So remember, like probably 5 years ago, architects waited like 2 hours for a picture with ray tracing and everything, and now they use a game engine which is real time, so they can actually move around in these renderings in real time. So it's pretty amazing, and that's fact. So we thought, what the architects can, VGS people can do too. So let's look into this a bit. Maybe here is a demo reel of a recent demo reel of Unreal, and just to get kind of a bit of idea. So what is a game engine actually? Actually, a game engine is a software development environment which is basically designed for people to build video games. However, of course you can also build other stuff, but it comes really it's an environment where you have basically all the stuff is there. Like, so of course you have very advanced 2D and 3D rendering, but you also have a physics engine with collision detection and everything. You have things like spatial sound, which is actually, or audio, which is very important also. Then you have all the stuff you need as a developer, like networking, streaming, localization, all that kind of stuff, like typical things you need as a developer. All is there, and this allows you to really develop these kind of visuals very quickly. It's really good development environments, and the good thing is they are becoming easier and easier to use. So it means people can actually, even in the meantime, you can use them even if you don't have programming knowledge. So did I forget something? Oh yeah, of course, animation. You can do lots of animation, and then the AI for controlling the behavior of your actors. So now for us, why are game engines something which is which is of interest for us. So yeah, on the first thing, what I already said, it's not just video games which you can build with this. You can build experiences with game engines, and it's not a requirement anymore to be a software developer to use this thing. So yeah. However, it's also kind of a change in paradigm for us. So for example, experience, it's not anymore a line of sight tool, which basically allows you to do many, many things. It's the other way around. An experience is basically, you create a specific user experience for one problem. So for example, find the sniper. You might use some technology which is obviously the same as line of sight, but it's really about this user experience, and then you create this game-like user experience to figure out that problem and only that problem. Or so if you build a racing game, you cannot shoot around, or it's for racing. So this is really kind of a change in paradigm, that it's about the end user experience which you're building for one thing in a very nice way. So that's why it's for us very interesting, for us as GIS community to use that. However, the problem is game engines are not georeferenced. So it means also like very large data sets give you problems, and you have floating point precision and all that kind of stuff. So that's the big problem. So now let's go into like Unreal versus Unity. So what's the difference between the two? And basically, what's interesting, both are basically for free. Means if you just do for personal use, it's for free anyway. But even for like you can, like I think Unity, the Pro version is $100 per year, and yeah. Only when you start really to become a publisher and have success and are successful with your game, then you start to pay. But also for indie developers, they have very good offerings. These two pictures actually show also a bit the difference between Unity. Unity is mainly used on more like the mobile games, so more like 2D. 2D, I think in 2D it's one of the most used engines, and then Unreal is more like for the high-end visualizations, the AAA games. From a technology point of view, like more from a graphics point of view, Unreal is actually quite ahead. So it means Unreal comes with much more built-in features. So it means you have in Unreal, you have, for example, this Blueprints, which is a visual scripting language. Then you have default materials, which are really good. However, what's really cool in Unity, on the other hand, is you have a huge huge of these indie developers, which give you lots of plugins, etc. Obviously, sometimes this stuff is not so good as these high-end features of Unreal, but yeah, it's a very living community you have in Unity. But typically, yeah, if you go for like high quality visuals, then especially because of the lighting system in Unreal is a bit better there. Then, from a development perspective, this is basically totally up to you. Yeah, Unreal has the advantage of the built-in visual scripting language called Blueprint, which is actually really, really amazing, really well done. But you also can have plugins in Unity to do kind of a similar thing. Then Unity is C# and JavaScript, and Unreal all in C++. What is pretty cool is Unreal source code for Unreal is public available. So this is actually a big advantage when you really need to go in and figure out what's going on. And yeah, it was a bold move of Epic Games, but I think it's really good. Then yeah, otherwise Unity very famous for its platform support. So like I think everything like yeah, Nintendo Switch and like every possible platform supports Unity. Yeah, I think even BlackBerry has Unity. So yeah, and also both are actually also for the browser platform. So it means there are WebGL versions of them. However, these WebGL versions are they are not there yet. Means often stability problems. And yeah, performance is not there yet. Yeah, the problem is in the browser tab you have about like 800 megabytes of memory, and that is for these kind of games a bit on the edge. Then the adoption, as already mentioned, Unity has a bigger community, especially of indie developers. And also the asset store of Unity is much bigger. It's really, really cool to browse that and look at it. Then we have with Epic Games, we have actually the owners of Unreal. They're actually really, really interested in non-game applications. That's something that they're pushing for this. So I think this just came out now, and they have this Datasmith. I'll talk a bit more about that afterwards. But this is basically their gate into the game engine, and where they try to fix all these technical problems you have when you bring in, for example, cat data into a game engine, or for us, for CityEngine data into a game engine. And also what's very interesting is they know that such an engine is actually, a game engine is not so easy to use. So they come actually with packages for learning and teaching and really focusing on industry professionals and not just game developers. So this is a really big advantage. In architectural visualization, because of that, is Unreal more used than Unity. But yeah. So, but for me, it's like it's basically it really depends on who your developers are and how much time you have and how big your project is. If you need to do a quick solution, then I would go Unity, but if you need to make a bigger software development project which you need to maintain over years, and then I would go Unreal. So, some examples. So first here, this is actually from Verben, a CityEngine user, and they had to create some kind of favela in Rio, I think, and so they created some CityEngine rules to create this. It's a pretty impressive rule set. And what's interesting now is like here you see, for example, all these effects and lens effects, etc. You get that all for free, and then of course you can also change for example, the daytime, and also here, for example, you can make it rain with like one mouse click. So that's the big advantage of like these tools. They are all there, and just with a few clicks you drag in the effect, and then it works. And it works in real time. That's the amazing thing. So here you see that's a time wrap. I think it's about like 8 times faster. So first you see doing the typical CityEngine thing where you have the rules and then wiggle around with the rules, and then at some point you export here. And so in CityEngine, then it uses this Datasmith exporter. Pretty fast there, like so the scene here is which you saw was about 5 minutes to export. Import took a bit longer, it was like 40 minutes, and now it's in Unreal. And now what you see is actually, so he's moving around a bit to different layers, adds a bit atmospheric fog, tunes the lighting, and really quickly. So now depth of field. All in real time, you can see it all, and then you have this. So and that was actually an intern which did that movie, and he really had done all this stuff in like, I don't know, like an hour or something. So you see, he has done it in one morning. Here is another example. This is from HOK. HOK is one of the big architectural companies in the world. And this is a huge greenfield project they have, I think somewhere in Turkey, about a huge city where they have to create a master plan. And we actually worked on our Unreal support together with them, and created. So that was kind of the first thing we did. And here, for example, see they added crowds of people walking around, and so for architectural visualization, these engines are very, very well suited. Here another example. So now Unity. This is a very interesting example actually from the city of Zurich. What they found an old settlement like 5,000 years ago in the middle of the city. And then they used CityEngine to create these buildings, and this is a public space where they wanted to build something in Zurich, and then it was exactly at this public space there was this settlement. And now what's the amazing thing is they created this, put that in Unity, and then into the HoloLens. And now what they actually did then was for the public, you could take your HoloLens and then actually walk around in the settlement like it was 5,000 years ago at the exactly same geolocated position, which was pretty amazing. And it's also the HoloLens here was super amazing. Like you could walk like 30 meters, and everything was still very well calibrated. So that was pretty impressive, user experience for what you can do. Then you could also interact with it. So here, and now what's also very good with Unity is, especially Unity, is you can now publish it not only for the HoloLens, you can also use it here for the Oculus Rift, or for, you can publish it on all different medias. And so yeah, here you see that the kid, yeah. But you see the visuals which are created are really, really amazing. So yeah, these are 3 examples. And now I just want to go in very quickly about, talk about how you bring in stuff into Unity with CityEngine. So this is basically via FBX. So yeah, just go through the quick steps, and afterwards I do the same with Unreal. So first thing is you can go in here, and then of course in CityEngine you can import stuff in CityEngine, so it can also come from Pro or whatever, and then export it. You use the FBX format, which is from Autodesk. It's a very good format. What you have to make sure is that you activate here texture atlases. These guys make that the textures can be wrapped and make the whole thing much faster. And also embed the textures. Then you actually already have it. You have here your project viewer in Unity, and so yeah, project viewer, here is the scene hierarchy. There's the inspector or details view, and then you can basically drag that guy, drag it in here, and then you already have your model in there. Now, then you have to move the main camera in there, and as a next step, you actually already could press play, and you could fly around on your screen. Now, when you want to add VR support, so it's like, for example, an HTC Vive, you can set up your Vive, and then all you have to do actually is activate this OpenVR support. And this is one of these tricks to figure them out that took us hours. It's you just have to drag the OpenVR above the Oculus, so, and then your HTC Vive works and your Oculus works. But yeah, so yeah, and then once you have that, all you do is all these game engines have that. They have a play button on top, and then you can always just press play and without any waiting time or whatever, and experience your game. So then the next step is now when we are in VR, then you want to add locomotion, and here now this is a typical thing where Unity is very strong. So you can go to the asset store and download the Steam VR plugins, and then with the Steam VR plugins, you first delete the main camera and then basically take the camera from the Steam VR. And once you have that, this plugin also provides so-called teleport points. So it means you can then take these teleport points and drag them in here. And once you drag them in, then again you press play. And now, because your Steam VR plugin is all activated, you have hand controllers, and you now can target one of these teleport points and press, and then you're there. So next one is actually then you want to teleport anywhere. So and then you have actually now a teleport area, and therefore you need to press. You need to first create a collider. So you select the mesh, and then create a collider. Problem is then it also creates some kind of copy or something. So yeah, you have to copy paste first. Then, yeah. So and then yeah, you assign again here the teleport area from here and drag it onto this thing. And as a next step, then you can press play again, and then you can yeah, teleport around on that street as you like. So this is like, again, like really simple. You can set that up. I think the problem is a bit like it's what's actually depends a bit on is the 3D model. Like FBX, FBX doesn't support doesn't optimize anything, or like only we in CityEngine we try to optimize a few things. However, we don't know the flavors of Unity. Nobody knows actually. Yeah? So means yeah, it's not optimized for Unity. So here and there you need then to go tweak materials or object count and all that kind of stuff. So, and this is a bit what Unreal tackled with their Datasmith. So that's their yeah, concept now, how they want to make game engines more available for non-game applications. And so how it works now with CityEngine is that you actually you export with this Datasmith exporter in CityEngine, and then there's a template for CityEngine for Unreal, and then you can import your file. What's now also good is at the very beginning you can, if you want, optionally you can reference shaders or yeah, or assign shaders from Unreal in CGA. Here quickly how this is done, just as a note. So in CityEngine you have this material.shader, and you can set that, and yeah, basically what you can do is just have. So we have in our VR in our CityEngine template we have 3 so-called Übershaders, one for opaque materials, one for semi-transparent materials, and one for masked. Masked means that the transparent parts are actually discarded. Yeah, but you also can create custom materials in Unreal, and then just via name control them. So in general, materials are always a thing in 3D. It's very hard to get the materials from one place to the other place. This is also in visual effects. It's the same problem. Then yeah, you with CityEngine you have the typical things where you can choose between the granularity of your objects. So do I have like just one object, or is it one object per window, or is the whole building one object? So that depends a bit always on your applications. And then you also can choose different instancing modes. So they typically have like very fast instancing and not so fast instancing. So when you have to repeat one 3D model many times, so they call that the foliage system, because it came actually from vegetation. And again, Datasmith takes care of all that. And then in Unreal, what you have is when you have the Datasmith, then you can actually see. Yeah, we are the 4th template there, and you then basically just create that project by clicking on that, and then afterwards you import, and then your lighting and everything and shaders will be set up. Typically you can just use, when you import then the file, the Datasmith file, you can just use the defaults only when you want to do some baking of light maps. So that means, for example, here the shadows of the wall, you want to bake them as a texture, only then you have to twiddle around with resolutions, etc. So, some basic principles of Unreal. So the idea here is now really that, because everybody knows, many people know Unity. I thought I talk a bit about Unreal, and show you guys a bit what it is about. So it's actually the same user interface, more or less, as Unity or as actually, all these user interfaces are the same. Like when you can use one of them, then you can use all of them. So here you have the workspace or the content browser, or however you want to call that, or in CityEngine it's called Navigator. Top left you have the scene graph, the outliner. Here you have the details, the inspector when you click on something. And here you have basically the library of prefabs, which you then can so these are your built-ins, which you can then drag into. So what's one of the things which is really, really impressive in Unreal are the materials. So we, for example, we have to, we also work on the whole platform, like on the whole ArcGIS platform. At some point, we want to have more advanced materials. So we had to study all the different approaches, like how do game engines and how does Walt Disney do it in their movies? How is it in GLTF and all these formats, etc., etc. And actually, one of the outcomes was that the de facto standard actually was Unreal, because they were basically implementing exactly the right thing and named it the right way, and looks really, really good. You have a graph-based user experience. So this is typical for material editing. So what you see here, for example, is that's the export from CityEngine, which is just normal color, and then what's done on the shader, so that's the default shader from CityEngine. They added here something that's the emissive color. So by adding that, it starts to glow. So here there's basically they do a clamp, probably a clamp if it's higher than 0.7 or something, then start to emit light. And again, then what it does is then a really, really kind of perfect glow, physically correct, and all that kind of stuff. Exactly the pieces which are very, very hard to implement, where you have to read SIGGRAPH papers and stuff. Then what's actually here? So what you have typically here are for example, these visual effects, and these are built-ins. So when you open that, you have all that stuff there, and I'm going to talk, for example, about 2 examples of these visual effects here. And then on the other hand, what you have here is also you have post processing. So means I'm going to show it in a sec. So let's first look at the visual effects. So for example, you have fog. So fog, again, physically correct. You have like 15 parameters how you can control this thing. And then you have different fogs. So you have also atmospheric fog here, and here again you can do scattering and all that kind of stuff. And you see here, for example, it's also kind of like a lens flare, and these are exactly these kind of physical elements which are very, very hard to implement. At some point, of course, we want to have all that stuff in Pro and JavaScript, and I'm pretty sure we will have it. However, it's just a lot of work. So post-processing. So this is also super cool. It's basically here you see a bit like how many parameters you have there. So what we have it's basically it's like Also, post-processing means it's just on the 2D picture at the very end. So, no, it's actually not just a 2D picture. But, so yeah, with the def. But for example, you can, def of fields, or all this lens stuff then you can do. You can, bloom is a famous thing. So bloom means if you have an area which is light up a lot, then it starts to glow a bit. So that makes it very, very realistic and very, this kind of gamey look. They always overdrive the bloom, and then it looks very, very gamey. Ambient occlusion, then also just 2D stuff, color grading. Well, it's like basically Instagram filters. And again, all that stuff is just there and just works. Here now a development example. So just that you get a few of the principles how that works in Unity. So obviously now you bring in data pretty easily, and then you can fly around, you can navigate around. But what do you do with it? So so here's an example, a pop-up. What's interesting is, for us a pop-up is a built-in, for them not. So yeah, but anyway, let's look at this. So here we have, so you click on that, and then you get the ID of the shape, and then of course you get some data, the attributes. And what we currently do is in CityEngine we export a comma separate value list, and then import them into Unreal. Now what you have in Unreal is besides this UI you just saw, is you also have a widget designer, and this is only for creating user interfaces. So, and these user interfaces, they can be heads-up display, so basically in front of you, like a pilot which has heads-up display, or they can be in the 3D world. There's actually even one widget designer for VR. They are pretty advanced in there, like really, really good. So you have this widget designer. There you can do basic things like drawing and etc. But you also can add some functionality by using these so-called blueprints. So let's go in. So means first you create this kind of visual thing here for my pop-up here. However, now I need to fill it with this data, and therefore I create a blueprint. So here's a blueprint example. So this is a little script, and it's just a visual programming language, a visual scripting language. And but what's really, really interesting is they have really tons of functions available. So here, for example, so this is now what we did here was this function get metadata. This get metadata gets a table, plus it gets the ID, so that's shape on 103. And then it returns the metadata for that shape. So it means here I have the whole CSV in there. Then I go in. I have my loop here, which goes through all the names, then compares them with the ID. If it's the same ID, then so here's that's a Boolean, or if it's the same, then add the data from here. So yeah, I think you get the idea of like how white is the control flow, and the other colors are parameters passed through. So yeah, you kind of get the idea on how it works. And with this, really lots of people are creating whole games just using this. And it's pretty impressive. And it's also what's really, really cool is how Unreal provides you also DevOps tools to actually really maintain these things and really manage the code or the script. Then one question is always, should I do C++ or this scripting? The standard answer would be, if it's computationally expensive, then use C++, otherwise use Blueprint. The core concept, if you code in C++ in this, is the understanding of like an actor. What is an actor in games? So this is an actor, is basically the same thing as in 3D or in CAD, an object, which is for us or in GIS a feature. So they call it actor, and an actor is basically an object which you put into a level and then it does something. And so yeah, and that's your base class for almost everything you do, and you then also see these actors basically in the scene graph. And how it works is actually that you create this that when you create such an actor. So here, for example, I create my actor, but derived from this class. Is then I can use this this in the blueprint and put it all together there. So here you see, for example, it's all done via. So here I have my expensive function, and then here I have annotation for Unlayer, and here this annotation U function has about 100 parameters if you really want to. If you don't put any parameters in there, then you just see here it just takes the name, kind of camel case here, and then makes it a nice name, and that's it. But yeah, so that's the basic core concept of it. Is with this you can really code standard C++. What's really cool is it's all smart pointers, garbage collection. Also, of course, the Unreal objects are also all garbage collected. So it's a really nice C++ development environment. So yeah, that was basically a bit of like Unreal in 5 to 10 minutes. So yeah, now I want to tell you about a project we are doing, which is work in progress, and something. Yeah, it's an R&D project where we are kind of interested also in feedback and beta users. So what we do is we want to create an urban planning VR experience, which is actually really based on this tabletop user experience. So tabletop means in virtual reality or actually augmented reality, you have this table and then you do stuff on that table. And so yeah, you look around and yeah, like it's shown there. And what's really cool on this user experience is that you can, it's very collaborative. So because you can stand around with somebody which is actually in your room or on the other side of the continent, and talk about a thing on this table. And yeah, people don't get motion sick, and so yeah, it's a really good user experience. And what we want to build is, first we want to really look into this tabletop user experience and really kind of make it work for us. And then on top of that, once we have that, we want to really create some urban planning specific workflows, where we know a few, and then really nail them basically in this user experience. So therefore, we are currently using Unreal. So again, because of Datasmith. So means what you see here is now currently this big city. You have to go through CityEngine and then export it as a Datasmith file. And then you have the city in there. Now what you currently need to do is, so it's basically our second Unreal template, and what you have to do is actually you have to scale it down. The whole city scale it down to some initial size. Of course, we will provide proper scripts to do that, and so that the whole city is fit on your table. So maybe that's also maybe a quick intermezzo. So yeah, this is also something we work on actually with the runtime team. At some point, we want to stream in, of course, these city models, and we want to use runtime for this. And yeah, so this is tomorrow in the VR AR session. We talk a bit more about that. So this is right after the closing session, at 1 o'clock. We have a session on VR AR where we talk about also about our plans in runtime for doing that. So now here you see now this user experience. So first, that's the other player. So there are now 2 players in here. They use HTC Vives, and now let's play it here. So here first he winks. So now you see here the table, And first thing is he modifies the table. He makes the table larger. It's also very cool. You can lift the table. And then there's this ring around it. And with this ring, you can basically take it and turn or scale your city. Then you have a laser pointer to point in there. Then you can do like this, and then you're getting this is also typical VR thing, you're getting the controls here. So now, I go here. So now he changes the scenario. So he changed now the scenario, the urban planning scenario here. So here are different scenarios. So he changed it now to another proposal. So you can look at that. So this is of course all very pre-alpha state, but yeah, it's the core idea is all as in VR. The thing which works is that you have here your basically menu, and then you do something there, and you do stuff there. And also, what you see are these teleport points here. Of course, the advanced user can teleport in always, but the idea now is. This is of course now, it's super impressive when you have this, when you are in VR or AR, and you then can have on your table a real three-dimensional model of your city, and you can interact with it, and then all in game engine quality, or like it looks really, really nice. However, the thing is, of course, you always look just from the outside. And then what you do when you want to have the full immersion is, actually what you can do is, you can teleport yourself into the model. So it means you're then very small on the table, walking around. And especially when you're two people, it's actually super funny, because then when one guy jumps in, you can go very near, and then you see him down there doing stuff. It's very small. And then you have your controller, and the controller is like 50 meters big for that guy. It was kind of interesting. But yeah, no, the idea is really actually that you jump in here. So this happens now. So oh yeah, first I changed the scenario back, and then you can of course change the light. And now he looks at the different points, and now I think the other one jumps in. So he jumped now into the scene, and now you can jump in there too. So now the two are in the scene. He winks again. And now they look at this scenario from the terrace from that other building. And again, they can switch, so they have the same controls, etc. So this is basically just the navigation part, what you see here. This is not yet any, we haven't solved any problem other than looking at different scenarios. So it means we have to then afterwards do stuff like, for example, the urban e-Thailand or whatever kind of planning problem we solve. So we are basically building here a platform for immersive interaction, where we can then put on top of this, we can solve problems. But the first problem is really the interaction, actually. So that's basically this part, and yeah. So to summarize, I think game engines are a very exciting platform to use. We at Esri, we look into this, and of course want to support it from different angles. On the one hand, from the backend side, So for example, with runtime, and then on the other hand, also from the user side, where we try to here, as you saw now, try to really do widgets and user experiences, and try to figure out how we solve. How we can really create compelling experiences with GIS data. So yeah, that was my little talk. Are there any questions? Yes?
Do you happen to know how Blender compares to these, if you use Blender as a game engine?
Yeah, the Blender game engine, I never played around with it. Typically, as I'm kind of like I'm a Maya person, so I never used Blender as a 3D tool. No, I never tried it out. But I'm pretty sure it's pretty exciting. I know some of the guys developing it, and they are very enthusiastic about it. But on the other hand, you have to see. I think be realistic. It's Unity or Unreal won the game. It's over. It's these two. and yeah. I think, for example, Autodesk also tried to build up a game engine, and they stopped. And it was in their press release. They said, "Our users want Unreal and Unity." Yes.
It's not a question, it's more about Unreal supporting Python automation.
Mm-hmm.
This has been announced at the Autodesk University in November. So Python was not mentioned, but just
Yeah.
it's coming down the line.
Yes. Yes. Yes.
What would be the optimal graphics card to run this on your PC?
Depends a bit on your experience. So, for example, yeah, if you have a Angry Bird or something, then you don't need then of course not. So it really depends on your experience. So this is of course like if you have, you can also do stuff which breaks your computer here, for sure. That's every software, but it just takes a bit longer then. But yeah, as this kind of thing, what you just saw now, that works on the standard PC. However, the favela you saw, which has like millions and millions of triangles, that's there you need like the latest NVIDIA card. And, yeah. But standard experiences like the one you saw, they run on your standard PC. I think even if you notebook. Yes?
Will we also be getting the opportunity of creating those FBX files directly out of Arcus Pro?
We're working on that. Nathan is back there. Do you have an answer? FBX export in Pro.
Yeah, that's right.
No, we of course know about interoperability requirements from our users, and try to do that more and more. So we added in Pro now, I think also OBJ and Collada, and they're adding more stuff there, import and export. And probably now with Autodesk being so close, yeah. But our higher priority is the BIM interoperability with BIM formats. So that's why in Pro we focus on the Revit thing first. Other questions? Yes?
Would there be an opportunity to participate in a best program for the last example?
Yes. Just come afterwards. Okay. So then, thanks very much. It was a pleasure. Thank you. And.